The tool we use today is called CLIP. It's from OpenAI, and it basically takes an image and it takes some text which should describe the image. It encodes them to the same embedding space, and by calculating the similarity between the image embedding and the text embedding, you can use it for zero-shot prediction. So we use it today for the Cypher 100 dataset. With this dataset, there's 100 classes, for example, of a kangaroo. And you have multiple options. So, for example, using clip.available models, you see all the models. You have some ResNet options, you have some vision transformer options, and then you just load the model and the image preprocessor using clip.load. So you specify the model you want to use. Let's say we use vision transformer B16. Put it to the device and set the model to eval because we're not training. So as you can see, it has an embedding dimension of 512 in the end. Before we start, we must preprocess the image. So the image input can be preprocessed using the preprocessor of the image. We unsqueeze it because we want to simulate a batch, because we only want to use a single image, and put it to the device. So let's have a look at its size. So it's a clip, takes the original image and transforms it to a 224 by 224 image with still 3 color schemes and 1 extra dimension because we unsqueezed it. We also must prepare the text input. So the text input can be prepared using clip.tokenize. With, let's call it a photo of A, because OpenAI used the same wording, and then Cypher 100.classes of 0, for example. So basically it looks like this. So this is a 77 dimensional vector. But they use padding, so they just use 1, 2, 3, 4, 5, 6, 7 different tokens to describe this text. And we do this for every single class. So basically, we change this here to a list. Where we do the same thing for every single class, and we put this to the device. And most likely I have a bracket issue here. Yeah, I need to concatenate it as well. Yeah, nice, no issue. So now you can see that the size is 100 by 77. Now using the image input and the text input, we can calculate the embeddings. Calculating embeddings is pretty easy. You just use model.encode_image or model.encode_text. So with torch.noGrad, because we're not training and we don't want to use gradients, let's call this image features, is model.encode image of the image input. We do the same with the text features. Model.encode_text of text input. And it's generally good practice to normalize them. So we divide image features by their norm. So dimension is -1. We keep the dimensions. So this should work, I guess. And do the same thing for the text features as well. Let's see. Okay, it works pretty nicely. Let's have a quick look at their sizes. So it's a 512 dimensional vector, as you could see up here already in the model. And now we can use those text features and image features to calculate the similarity score. So let's do this. We calculate similarities by multiplying by a number so it looks nicer. Then we take the image features, run a matrix multiplication with the text features, transpose them, and take the softmax so we get nice probabilities instead of just logits. Then we can print the top values and indices of those classes with the highest probability using similarity.topk of, let's say, 5. So we get the 5 classes with highest probability, and then we just print the predictions. Now we take the values and indices and print the classes and their respective percentage chance. And as you can see, it has a 98.8% probability of being a kangaroo and less than 1% chance for all other classes. So it's a pretty good classifier, especially because it wasn't trained on the specific data set. It's just a random data set I picked from the internet. Maybe it was trained on it, but you could basically use any data set and the results are pretty good, I would say. You could also use k-nearest neighbors to classify the images. And if you really want to use training, you could either fine-tune CLIP on your training data, and I'll create another video on that. Or you could take the image embedding and then train your neural network to which takes the image embedding as input and outputs the probability of each class. This is my first video ever, so I'm pretty excited to join YouTube. I want to use this channel to basically document my learnings as a data scientist. So if you aspire to be a data scientist or you are already one, just hit the subscribe button and learn with me.